Hey, welcome back. We are in grade 6, unit 5, lesson 12, and today's lesson is a superhero lesson, so that's pretty cool. Many of you know I'm pretty crazy about superheroes because of my family. We're all crazy about superheroes. So, today's lesson is about some soup that apparently keeps superheroes going with their awesome abilities. So I'm on page 264 and we are looking at vats of soup. Now, the word vat means like kind of like a giant tub, and you can think of it's a factory even bigger than this. Like this is the biggest one I have, but if it's at a factory, you can think of just a giant container that holds soup, and that's what we're going to be talking about today. So today we're talking about how fast the soup goes into the vat, how fast it goes into the giant tub, where I don't know, it's mixed or something happens to it. So it says superhero supplies produces different superpower soups. In the factory, each type of soup flows into a different vat. So in this particular case, T is the time that it takes. So you see, I've written this here. This is also in your book. T is the time that it takes, and V is the liters, the amount of soup in liters that comes in. So T, if you're wanting the soup that's super strength to give you super strength, that flows into the vat at T times T, whatever T is, however much time has elapsed, squared tells you how much soup is in the vat. If you're looking at the X-ray vision soup, 5T means 5 times T. Whatever the T is, 5 times, that's how much soup there is. Flying, V, the vat, how much soup there is. If you want to have the superhero flying soup, it's going in 5T, 5 times the time, plus an additional 3. Whoops, that's my Roomba turning on. It's kind of loud. Hold on one second. All right, we're back. Lightning speed. If you want to have lightning speed, the soup comes into the vat, into the mixing vat, at 2T, means 2 times whatever the time has gone by, plus 10. That's how much soup in liters you have. And invisibility. If you want to be invisible, the soup that you need comes into the vat at 3T, 3 times the time it takes, plus 10. And that's how many liters there are. So we're going to compare the soups and see if any of them are coming in at a constant rate, means it's the same thing over and over and over, and if any of them are coming in at a non-constant rate. And we're going to try to graph that and see what that looks like when we graph that. Okay, we're back and we're going to look at number 7. Number 7 gives us a table to fill out about how many seconds have gone by and how fast the soup has come pouring into the vat. So if you imagine in a factory, you imagine there's probably a big tube coming down on the ceiling and going into, and again, this is the biggest one I have, but at a factory it would be huge, even bigger than this. And it's filling up, it's pouring the soup into the vat to get it ready to cook or mix or something like that. So this problem is asking us to make a table about the time it takes for the soup to start pouring in and then how much soup. And the first question, this number 7, is about vat number 1, about super strength. So you can see I've drawn it in green to kind of help us delineate the different kinds of soup. So super strength for me is green. Doesn't have to be for you, but if you can use different colors, just like you hear me say in class all the time, if you can use different colors, it really will help you keep yourself organized. So the formula is how much soup, V, the number of liters of soup in the vat, is equal to the time times itself, so time squared. So 0 is the T, so V equals 0 times 0. Well, what's 0 times 0? Well, that's 0. So over here, I'm just going to write this was 0 times 0. 0 multiplied by 0. Now, what if time is 1? That would mean that the V would equal 1 times 1. One group of 1. 1 times 1 is 1. What if T, the time, was 2 seconds? You can just do what I'm doing right there, right over on the side to help you. It's 2 times 2, which is 4. What if the time was 3 seconds? Then V equals 3 times 3. Continue going in this pattern and pause the video a second and fill out the rest, and then come back and check it. Okay, so take a look and see if your table looks like mine. Each time we were finding the value for V, how much soup was in the vat, in liters, each time we were using the formula that 1 liter equals the time squared. That's how fast the super strength soup goes in. Now, the next question asks us to graph that information. Now, the tricky thing about this is I'm not very good at graphing up here. So I actually did what some of you are doing in that I printed out a piece of paper from our student activity book, and I'm going to draw right on that paper. So you can see, I'm going to hold it up here. You can see that I went ahead and filled out in green our table, just like you did. And then I started graphing, and it's a little tricky to see, but I hope you can see it. How did I graph it? Well, it says plot the points. The seconds are going across the bottom, and the liters in the vat are going up and down the side. So 0, 0 just starts at the origin. So you see my first dot I put right at the origin, 0, 0. Then 1 and 1 right there. So where 1 second crosses with 1 liter, I put the dot right there. Now this is where it gets kind of surprising. At 2, it's no longer 2, 2, it's like 0, 0, 1, 1. It's not 2, 2, it's 2, 4. So the seconds is 2, so we have to go over to the seconds, but then we have to go up to the 4 because there's 4 liters. After 2 seconds of filling, there's 4 liters of soup. Then look at 5. Oh, I'm sorry, 3. After 3 seconds of filling, it goes all the way up to 9. After 4 seconds of filling, it goes all the way up to 16. After 5 seconds of filling, it goes up to 25. And after 6 seconds of filling, look at this, it's way up here at 36. So pause the video a second and go ahead and plot those points if you haven't already done so. Okay, now it wants us to know if that is a constant rate. And if you think way back to the beginning of the year when we were talking about constant rates, we said it changes by the same amount every time. So that's what makes it constant. So let's look. Now, the time is constant because every time it goes up 1, up 1. 1 more second goes by, 1 more second goes by, 1 more second goes by. So the time is constant, but let's look at the rate of the soup going into the vat. From 0 to 1, it went up 1, plus 1. From 1 to 4, it increased by 3. We added 3. From 4 to 9, it increased by 5. 9 minus 4 is 5. Plus 16. Oh, when it went from 9 to 16, that went up 7. When it went up from 16 to 25, that went up 9. And when we went from 25 to 36, that went up 11. Is that a constant rate? I hope you're saying it's not. You can see it's not going up by the same amount. Now there is a pattern. You might be able to see noticing the pattern, and good for you. That's great. There is a pattern, but it's not going up at a constant rate. So this super strength vat super soup filler, whatever I'm trying to say there, it doesn't fill up the vat at a constant rate. Okay, let's go on to page 265, where we're now on to VAT 2 and VAT 3. And we're going to see if those are a constant rate coming in. Well, let's see. VAT 2 has X-ray vision, so if that's the superpower you wish you had, this is your vat of soup to eat. So notice that the formula for how fast the X-ray vision soup comes in is the liters, the vat. V is the amount of the soup in the vat in liters. So the amount of liters that are coming in are 5 times the time it takes. 5 groups at a time it takes. So 0 times 5 is 0. 1 times 5 is 5. V equals 5 groups of whatever the time is. So 5 groups of 1 is 5. 5 groups of 2 is 10. 5 groups of 3 is 15. You can see each time we're just putting the time in this right here, and then we're solving for V. V equals 5 times whatever the T is. So pause and fill out that chart for a second. Okay, so take a look. Hopefully your chart looks like mine. And I'm gonna have you go ahead and go to VAT 3 for the flying and fill that out too. And then we're gonna graph. So get a different color, just like I have purple for X-ray vision. You don't have to choose purple, it's okay. But choose a different color if you can for flying. All right, so I've chosen red for flying. So I've got my red marker. Now this is an interesting formula. It says the V, the amount of liters in the vat, is equal to 5 times the time, 5 groups of the time, plus 3. That kind of means that 3 is where they're starting. So they're already starting with 3 liters in the vat. Why? I'm not sure. Maybe that's just how the factory does it, but it kind of means that there's 3 already started. And let's see what that looks like when we fill out the table. So normally, if you remember, when the time was 0, the amount in the vat has been 0. When the time was 0, the amount in the vat was 0. But look at how this formula works. V, the amount of soup, is 5 times T, so 5 times 0 is 0, but then plus 3. What's 0 plus 3? Well, that's 3. So in this particular case, the vat isn't starting empty. It's starting with already has 3 liters in there. So then let's see how that progresses. So let's put a 1 in for the time. So 5 times 1 is 5, but we still have to add the 3. So in that case, the amount of soup is 8. Let's try a second one. This time the T is 2. 5 times 2 is 10, but we still have those extra 3 that we started with. So now instead of 10, we're at 13. Let's try one more. Now, what about 3 seconds after the soup starts going into the vat? 5 times 3 is 15, but we still have those extra 3. So now we're at 18. Pause and see if you can finish the rest of this table. Okay, so when you did, check to see if yours matches mine. And also, do you notice a pattern here? 3, 8. Then it ends in a 3, then it ends in an 8. Then it ends in a 3, then it ends in an 8. Then it ends in a 3. If it keeps repeating back and forth like that, that can be a helpful tip to tell if it's a constant rate or not. So let's graph these two and then talk about both of these, VAT2 and VAT3, talk about whether they're constant rates. Okay, here's my sheet, and I hope it looks kind of like yours. So go ahead and plot those lines, right? Those dots right on the graph. And you'll see again, I used the 2 different colors because it's really helpful. If you don't have 2 colors at your house, maybe use a pencil and a pen if that's a choice. Otherwise, just use what you have. But you can see because I used the 2 colors, it's easy to tell which line is which. Now, here's another that we're going to talk about 2 easy ways to tell if something is a constant rate. One is you can notice the change and see if the change is the same. So let's start with VAT2. The change from 0 to 5 is 5. We're talking about the liters here, right there. Right there. The change from 0 to 5 is 5. The change from 5 to 10 is 5. From 10 to 15 is 5. From 15 to 20 is 5. From 20 to 25 is 5. So you see, and I'm going to put this down a second and add those in and write those down, but it would be helpful if you actually did the same. So pause and write this down with me. Okay, each change is plus 5. We know from earlier this year, if each change is plus 5, we know that means it's a constant rate. So we know VAT2 comes in at a constant rate. Let's do the same thing for VAT3. What's the change between 3 and 8? What's the change between 8 and 13? What's the change between 13 and 18? Pause and do that too. Okay, notice that that's the same. Each change is still an additional plus 5. We're adding 5 each time. So to the liter. So that's a constant rate. It means after every second, 5 more liters come in. After every another second, 5 more, 5 more, 5 more. We continue to add 5 liters at a time. Now, the second, remember I told you there's two easy ways to tell if it's a constant rate. One is if the numbers these numbers here are always the same. Plus 5, plus 5, plus 5, plus 5, plus 5, plus 5. That's a lot of addition. So if we're adding 5 each time, that's a constant rate. The other way is to take our ruler and see what kind of a line we drew. If we can make a straight line through our points that we plotted, it's a constant rate. If we can't make a straight line because the points or the dots don't line up in a straight line, then it's not a constant rate. So grab a flat edge. It doesn't matter, a straight edge. It doesn't have to be a ruler. It could be the side of your book. It could be anything that's straight, and connect your dots, both on this one and also from that one. So go ahead and connect your dots and be right back. Okay. Well, when you did, hopefully you noticed that your lines were straight. Both lines were going straight up across the graph. And the only difference is the one from vat 3 is offset a little bit because it started with 3 liters in the vat already for whatever reason. But aside from that, the lines look exactly the same. They're following exactly the same trajectory. So they're both constant rates. But let's go back to vat number 1. When you did that with your ruler, what happened? Well, I hope you noticed you had to keep turning your ruler. You couldn't make a straight line. You can even see that when you look that it's completely not a straight line. If it's not a straight line, the answer is no, it's not a constant rate. We noticed it wasn't a constant rate when it didn't go up by the same numbers, and now we can notice it's not a constant rate because the line isn't going up straight. The line is kind of making like a curve going up. Okay, lastly, I'm just going to help you take a look at the two tables for VATS 4 and 5. And if you have not done those on your own yet, please pause and try to figure them out. And if you have, I'm going to give you a second to pause before I show it to you. If you have, then take a look and see how you did. But if you haven't, please do pause and take a look. All right, so there they are. If your favorite superhero power is lightning speed, there's the soup for you. Notice that it follows the same pattern as the third vat. It's 2 times the time, 2 groups of a time, plus additional 10. Remember, we mean for whatever reason, the lightning soup is starting with 10 liters already. I don't know why, but it is. And so there's already 10 liters in before we start putting more soup in. So the time is 0. The vat already has 10. Now, what about the next one? 2 times a 1, the time is 1, 2 times 1 is 2, plus 10 is 12. We keep doing the same pattern, and you can notice that it's increasing by 2 every time. If it increases by 2 every single time it does, is that a constant rate or not? I hope you know that. If you don't, go back to the earlier part of the video. What about this one? Invisibility. If that's your favorite superpower, here's the soup formula for how it goes into the vat. It's 3 times the amount of the time that comes in plus 10. So again, this one also is starting. There's 10 liters already starting the vat. So there's no time has gone by and there's 10 liters. How do we know that? We put a 0 in for the T. 3 times 0 is 0 plus 10 is 10. So then we continue to put in the time, the seconds, we get rid of the T, and instead replace it with the actual time to find the formula, and we find that it is increasing by 3 each time. So I hope this lesson was kind of fun for you, especially if you like superheroes. In the comments, tell me which is your favorite superpower, and it doesn't have to be one of these. It might be something else, but I hope it's math, actually. I hope math here is your favorite superpower. So see you next time. Bye.